And I think we are about to go live. We're just waiting to connect to all the other social medias out there. Let's see whether or not we're ready to roll. And we're on X, and now we look at this. It actually moved faster. There we go. Make sure I don't have any feedback there. Alrighty then. Welcome back. We have a lot to talk about tonight. First of all, some sports news. The Braves are losing, which is great news for the Mets. Yes. And we have a lot of interesting weather stuff going on, of course, as well, which is why you're here. Duh. We have a landfalling hurricane. We have some tropical mischief, maybe off the southeast coast in a few days. We have a new tropical depression, which is likely to be a tropical storm pretty soon. And there's a lot of interesting data showing up for the cold season that kind of has me wondering what's going on here. So I'm going to share with you tonight some of the observations which have also been talked about that you probably see on X, like Judah Cohen, for example, does an excellent job with going over all this data. But it's not only that, it's also the sea surface temperatures. There's a lot going on here that, as I'm trying to formulate the winter forecast, I'm kind of stepping back saying, this is going to be more difficult than just, hey, La Nina, copy paste, move on. So some interesting data to say the least. But first, let's dive into the observations. And of course, we have Hurricane Francine that has made landfall. It's lifting through Louisiana, and it is getting ready to, well, it's starting to weaken at this point. The good news is that it didn't have its chance to rapidly intensify, which is great news, all right? It got to 100-mile-per-hour winds being reported from the National Hurricane Center via observations from the Air Force planes. There's been some discrepancy with some surface observations, but there have been a few buoys reporting those winds near 100 miles per hour. So, yes, it was verified, but because of the nature of this storm, where you didn't have a complete eye wall and you have segments here that were weaker than others, there's a good chance that many locations were around 75 miles per hour winds, which are still strong, still capable of producing damage, but not as significant as, let's say, everyone getting 100 mile per hour winds. So remember, when it comes to these warm core lows, the strongest winds are very, very concentrated. All right. When you're talking about a 100 mile per hour wind hurricane, that doesn't mean the whole storm is featuring 100 mile per hour winds. It means that there is a core in here producing 100 mile per hour wind. So if you're outside of this core, what you're pretty much worried about then is very heavy rainfall. And of course, the storm surge that will be an issue for portions of the coasts of Alabama, Mississippi, of course, and Louisiana. But those strongest winds are really concentrated. So I know that there's a lot of stuff on X and even Facebook and whatnot that goes off on the idea like, well, I didn't experience these strongest winds, or I haven't personally experienced these observations, so therefore it's some sort of conspiracy. No, it's just the nature of warm core lows. The nature of warm core lows is that the winds are very compact, very, very tightly wound around the low pressure system and in very concentrated areas. Whereas extratropical storms like nor'easters, in my opinion, can be more destructive. Why? Because the stronger winds are expanded out. It covers a farther area. It can lead to more coastal flooding in more locations, and it can produce more precipitation in a greater area, right? Whereas warm core lows are, again, very, very concentrated, like what we're seeing here. So it is starting to lift northward. Oh, bless you. It's my wife. You okay, hon?
I'm all right, yeah.
Okay, good deal. No problem. Francine is lifting inland, and it will steadily weaken from here on out, okay? And it will become a tropical storm. It will continue to lift into the Mississippi River Valley as it's basically entrained into this trough and become what we call post-tropical. Now, this pattern that we have in place here is very, very interesting because what we're setting up is a split pattern. As this trough intensifies and takes in what's left of Francine, it's going to help to pump up this ridge here. This ridge is going to be settling over our neck of the woods, continuing the extremely pleasant weather conditions we've been dealing with, and also enhancing some of the 850 millibar temperatures, so we rebound into the 80s. But again, the overall theme is that it's going to be sunny and dry all the way on through the weekend. The concern that I have with this pattern is that as this trough gets trapped under this ridge complex and produces what we call a Rex blocking pattern, what that does is that it sets a surface high pressure system locked in around the Gulf of Maine, and that drives easterly winds into our region for several days. Now, not strong easterly winds, we're not talking about 10 or 20 mile per hour winds, but because they're persistent, they start to allow a gradual buildup of our water on the East Coast, on the coastal plain, right? So every time we have a high tide, some of that water doesn't exit out. The problem is that we happen to be moving towards astronomical high tide. So next week may be a bit of an issue with the threat for coastal flooding. Now, when we take a look at the observations here, let's take a look at a water vapor satellite picture. This setup here that is evolving here, some people are starting to, let's say, wonder if there is a big storm on the way. Not really, okay? And here's why. Here's what the reasoning is. This feature is going to get trapped under this ridge and get separated from the subtropical jet stream. And so what's going to happen is that it basically minors itself out. And when this starts to set up, the ridge that sets up over us, it becomes very strong. It's not going to give way. So as a result, this feature, it basically weakens until this ridge starts to slowly break down. And none of that really takes place until the polar jet stream, which is going to remain back here, really knocks everything down. So you can see this evolution all showing up here on the water vapor satellite picture. This is a great example of how you want to use the observations before you get wrapped into all the model guidance, okay? Model guidance is going to try to knock down this ridge too fast, amplify storms too much, create a lot of feedback error, convective feedback. So what you want to do is, based on your experience and the observations you're seeing right here, you start to pick out some details here. Okay, so first detail is that this tropical system is not as strong as what some of the earlier model guides were showing. Why is that important? Well, the residual short waves associated with this tropical system that's going to be meandering out here and kind of festering out here in the southeast coastal waters are not going to be as strong. So your base development is going to be weaker than what some of the model guides like the GFS and the European were suggesting. So now we have those observations in place. Then you look at the polar jet stream, and you see this trough is pretty robust here, which means that our polar jet stream is going way to the north. So we're trapped in between with a lot of subsidence, a lot of sinking air starting to build here around this whole structure, which basically tells me that anything that tries to develop here, it's not going to be moving all that much. It's going to be drifting back, retrograding back towards the coast. And even if it does pick up some minor tropical characteristics, it's not going to be able to sustain a true warm tropical low because of this dry air. See this dry air to the north here? This is going to lead to more of a baroclinic development rather than a pure warm core development. So all these observations say, okay, step away from the major storm idea that some of the model guides were showing, and that I really wasn't buying. I was like, all right, scattered showers, I'm not buying like 3 inches of rain stuff. We're going to step back from that. Look at this as more of a persistent easterly wind component issue for the northern mid-Atlantic rather than a major coastal storm. So when we study all that, we see that, what that potential is. And I'm going to come back to this in a moment. I want to go next to studying the rest of the tropics. Because, again, there's a lot of stuff on social media. Some individuals or organizations, say some news organizations, are really trying to push the idea that, oh my God, it's the hurricane season. It's going to be super active, blah, blah, blah. Look, the super active idea is dead. It's dead. It is absolutely dead. It's shot in the head. It's dead. It's with Grimm. Okay? It's done. Okay? So that idea busted. My forecast is going to bust. Everyone's 33 storm forecast is going to bust. Everyone was saying, Steven, you're too low at 20. So that is going to fail. So we just need to accept that. Why? Why is that the case? That is the key question to ask. Not, oh my God, is the world going to end because of one storm or because a storm made landfall? Why is it quieter? Because if you don't know that answer, you're missing a key component in the winter forecast. Think about that. Let it settle. Let it settle in your head. What have we seen? An active subtropical jet stream. A subtropical jet stream that is not falling away, disappearing. And so what has that led to in the Atlantic? More vertical wind shear, more dry air. I'm not calling this an El Nino pattern because it's not. But it's certainly not a La Nina pattern either. There are several reasons, and there's a lot of debate going on in the atmospheric field right now. Is this because of Tonga? Is this because of climate change? Is it a combination of both? I think it's a combination of both. Look, again, the worst thing you could be is full of your hubris, thinking you could figure all this stuff out like that. Okay, you're going to make a lot of mistakes, and making declarations that it is definitely X or Y when it could be X plus Y, and how they interact, maybe creating complete and total havoc in our weather pattern. So it's very interesting to see what is evolving here in the tropical zone, in the MDR of the Atlantic. We do have a new tropical depression right here. It's likely to become a tropical storm. Don't worry about it, though. It's not a major threat for us. Why? Well, because of this trough here. You see how these clouds are moving south to north? Yeah, this thing is about to run into a buzzsaw. Okay, so it's going to march along. It's probably going to become a tropical storm. Okay, I think it would be G. I forgot what the G one is this year. But I wouldn't be surprised if a tropical storm tonight, in fact. Okay, it's not going to take all that much to get there. So this is likely to become a tropical storm, and it's going to run into this dry area. You can see some of the vertical wind shear here and here. And oh, by the way, this disturbance, which a couple of days ago was as high as 70% chance of developing, is now down to 10%. Why? Dry air. The dry air in the substance is murdering this thing. And we've seen this theme all summer. Interesting, is it not? Just something, again, put it back in your head, let it fester, think about what is happening to the atmosphere as a whole. Okay, because the atmosphere is not 2D, it's not 3D, it's 4D. And there's all these different factors interacting and combining with each other and pushing against each other. And it's our job to kind of figure out, okay, what's happening here? So this is likely to march along. I don't see any other significant waves coming off the African coast. And when we take a look at the forecast here for TD7, let's see if there's any update. In fact, since it's 8:14, nope, no update yet. Probably 11 o'clock. This will, again, likely run into that buzzsaw. It's only expected to strengthen into a tropical storm and then start to weaken, and then it'll curve northward. Model guidance here takes that feature and clearly turns it north. Now, just a refresher on how to read these models. This isn't individual storms. This is one component, and then it takes that one storm, and it has several different models that produces different solutions. So, like, for example, that one feature that we were talking about that the dry air is killing, that's this. This is our tropical depression that's likely going to be a tropical storm. Notice most guidance turns it northward. This is that tropical feature that we were talking about off the southeast coast that is likely to meander off the southeast coast and then retrograde westward. There are a few models that suggest it might meander out here towards the Atlantic, but this solution right here had the high pressure system weaken way too fast. Again, when you have a Rex block, these high pressure systems don't just collapse. They tend to put up a fight. So this is a little bit less reliable. So you have this feature more, and then that's it. That's it. In the middle of the hurricane season. This might be the big, fireworks finale type scenario. Of course, we have to get all the way through September and October. All right. So I'm not saying that we're done in any way, shape, or form, but we're not seeing string storm after storm after storm marching off the African coast either. So certainly some interesting data. Great news for the East Coast. Hopefully everyone is okay in Louisiana. This storm, the good news with this storm is that it's lifting northward and it is exiting at a pretty quick rate. Now, as far as the next couple of days heading into the weekend, remember I was telling you about that ridge? There it is intensifying. And as that Rex block really intensifies, what's left of our hurricane, starts to lead to a weakness here in the coastal waters. And what you end up with is this hybrid type scenario here. Now, yes, it can pick up tropical characteristics. But let me be very clear about this. Just because a storm has tropical characteristics does not make it stronger. There's a lot of connection to or thought process that, oh my God, they named it, so it must be some horrible storm. Not necessarily. The difference in the storm is the structure of the storm, not the intensity. When we name a tropical system, it's because of the structure of the low having a warm core structure. That doesn't mean that it's stronger than a nor'easter or any other type of storm. A nor'easter can be much stronger than a tropical storm, and vice versa. It's just a matter of what that structure is. And then within those structures, within a nor'easter, for example, you can get what's called a warm core seclusion. And when you get a warm core seclusion, what that looks like, it literally looks like a nor'easter with a little eye, right? So a lot of people say, oh my God, it's becoming tropical. No, it's the warm core seclusion. It's the warm air wrapping around the core of the low pressure system with cold air coming into the middle. And it's kind of creating like a little bit of a swirl. It's really cool to see on a satellite picture and on a radar. But the structures in terms of the way that it's creating lifting over the region, in the atmosphere, are two different processes, right? If I was going to put it into different terms, it's the difference between someone who uses a lot of energy with carbs and fat, right? There's keto, there's that way, and then there's carbs, high carb diet, right? They're both using energy. It's just different ways of energy, right? It's different processes in the body. Same thing with tropical systems and extratropical systems. There's storms, but just different processes. So just because something picks up tropical characteristics does not make it more intense or stronger. It's just a different process of development in releasing latent heat and trying to balance out the differences in the atmosphere. So I want to make that very clear because there seems to be some sort of misunderstanding in the idea that just because you have a named system that therefore it's a powerful storm. I know on the news they have all these fancy graphics and they get the great drama songs and the music. Like every time that something breaks in, they got the drums going and all that stuff. It's very dramatic. It's very, very cute, but it doesn't need to be like that. So this feature locks in, and what this tells me here, when I look at the 500 millibar pattern, is that if you're on the coast, prepare for coastal flooding. not from a powerful storm, but from a persistent easterly wind driving the water right into the coastal plain, as I discussed. When we take a look at 500 millibars on the ensemble guidance, you can see that Rex block really holding strong. The ensemble guidance has been pretty consistent with this, weakening this feature, keeping this feature weak. The primary deep trough in this whole pattern, the monster trough here, is really what's sitting here on the west coast. This is driving our polar jet to the north, setting up our Rex block. This feature, very weak. It minors out as our polar trough starts to shift towards the Rockies and towards the plains. That's when this feature begins to collapse. And so what you end up with is a weak low pressure system around North Carolina and a strong high pressure system in this area right here. Why? Because this negative NAO factor here, which we'll touch on in a moment, is going to lead to convergence and confluence, so air converging aloft and then sinking, and that sinking air enhances the potential for a strong high pressure system. At 850 millibars, just kind of showing you, there's that easterly wind that locks in. So we have it at 850 millibar level. There is our feature to the southeast. Again, notice not much in the way of strong PVA here. Okay, so what this basically tells me is like weak lifting coming off the ocean, scattered showers, variable cloud cover. Not a major storm. As far as moisture available in the atmosphere, by the time we get to next week, yeah, there's some areas where we got precipitable wave ice approaching 1 inch, but really the deeper moisture stays to our south. So again, showers, brief heavy downpour, not the end of the world. 850 millibar temperatures moderate nicely, but then we start to get more of that maritime influence. So again, not a huge scenario in terms of any type of heat or cold weather. Temperatures basically in the mid 70s to mid 80s through this period. A few locations as we head to this weekend may push to 87, 88 range because of substance, especially around, let's say, Philadelphia, southwest New Jersey. But again, nothing that is too high or too low in terms of extreme temperatures. And then here's our surface map. And this is what's really key here. You see this high pressure system here? Now you get this little weak trough here hanging around here. So this sets up your easterly wind. Not terribly strong. We're not looking at 20 mile per hour winds here. We're talking about 5 to 10 miles per hour sustained. And then on top of that, the astronomical high tide, which is going to enhance the potential for coastal flooding. If we didn't have this pattern, we'd already have minor coastal flooding likely during this time period. Now with this persistent easterly wind, guess what? That's going to be pushed into some moderate flooding potential. So again, if you're on the immediate Jersey Shore, Long Island, the Long Island Sound, Connecticut coast, be prepared. Okay, have some kits ready. Maybe get some sandbags if you're right on the beach there. Some of those properties, just be prepared for that. Don't be caught off guard. And this feature, I know that some people are going to try to pull like climate change. No, this is not that example. Bad example for that. This is simply a persistent easterly wind. Okay, you would have flooding if this was 1940, 1980, or 2000. Right? It doesn't matter. It's the same scenario. And you see this persistent easterly wind just keeps on rocking and rolling. And yes, I do notice that there is a nice tropical system out here in the Atlantic caused by another different tropical wave. But notice it's nowhere near us, not really a concern. So I'm not really worried about that just yet. But again, for our neck of the woods here, primary story, by the time we get to Tuesday, we finally get a few showers. Not a washout, not a major rainstorm or anything of that nature. And we get a lot of that persistent easterly wind locking in. And that's also showing up nicely on the ensemble guidance as well. So I hope I leave everyone's fears, because I've seen a lot of people asking questions about major storms and whatnot. Not really. At least not yet. Now, what has my attention is this. Negative NAO. Well, hold it. You're supposed to be developing a La Nina, and you have a positive QBO. Not exactly what you would expect to set up a negative NAO pattern. So what is going on here? And is this something to continue to follow through for the cold season? As after all, the 46-day shows after a bit of a weakening towards mid-October, we go crashing right back into a negative state again by the time we get to the end of October. Just in time for our wedding anniversary. Wonderful. Which typically means stormy conditions. But this is supposed to be La Nina. And the positive QBO is supposed to set up more of a colder stratospheric environment. So what's going on here? Because this signal should stand out to me. All right, it should stand out to you too. Well, we know our La Nina is developing. As you can see, it's a heck of a lot more robust than what it was just a couple of weeks ago. Clearly focused east-based. Our negative PDO showing up very nicely now. It's starting to set up that colder water, and it is just boiling out here. I mean, I typically don't like to use the word boiling, but I don't know how else to describe the well above normal water temperatures out here. So I think what's happening here is that this feature here is helping to enhance a lot of short waves in the polar jet stream around the Gulf of Alaska and the Aleutians. It's amplifying the polar jet stream more than what you would expect and what the model guidance is adjusting for. The east-based La Nina would tell me like, hey, look, this opens up the potential for some convection and thermal gradient right around the date line. Enhances your subtropical jet stream. The atmosphere is not behaving La Nina-like, possibly because of some of the influence from Tonga. Okay, and the reason why there's possibly some of that influence, I actually had this debate with someone on X who, I guess because it wasn't an overwhelming percentage in the atmosphere, that therefore it doesn't have an impact. This person was very much pro global warming, so I explained to him that's a really bad argument because carbon dioxide is less than 1% of the atmosphere, so you really don't want to use that argument. What you want to understand instead is, hey, look, this type of injection of water vapor, or in this case carbon dioxide, has a huge impact on the chemical makeup of the atmosphere and how different features in the atmosphere interact and warm and cool the atmosphere. So when you're adding water vapor, even though it doesn't seem like a huge amount to us, when you compare that to what's normally in the stratosphere, it's a big deal. And it's disrupting the vertical and horizontal circulations that we normally follow. Now, how that's happening, I am still grappling with. I am still having a difficult time trying to figure that out. The equations don't work out. The influence on the jet streams is becoming a difficult issue to figure out. But I think I'm getting close. Unfortunately, you're going to have to bust and make errors in order to figure that out. But when I'm looking at this environment, this would technically, without considering the positive QBO pattern, this signature out here would technically support a negative NAO pattern. So there is that factor right there. The positive QBO certainly would support the development of a stronger polar vortex, but that doesn't mean it can't be displaced. And that doesn't mean that the polar jet stream can't be amplified. It just typically means the blocks aren't able to hold as long. So a lot to work out there in that respect. As far as the atmospheric influence, as you can see, we've had some major changes in our SOI. We are shifted into a positive state. The monthly value is up to around 10. The seasonal value has finally gone into a positive state. So, ladies and gentlemen, any doubt that the atmosphere was going to eventually move towards La Nina, I think can be answered. Yes, it will. It is. It's in the process of doing that right now. it looks like weak signal. Okay, I'm not seeing a huge spike. I'm not seeing any indications of a powerful La Nina or moderate La Nina. Weak. And that's pretty much been in agreement with a lot of the model guidance. So there's a few stray that are going towards moderate. I know that one European guidance solution came out where it was suggesting a moderate La Nina. But when you look at all the observations and the trends that we've been keeping an eye on, it looks more likely to be weak. We'll continue to keep an eye on it. You don't want to close the door on that and try to ignore data that's developing. But certainly, this would suggest weak east-based La Nina, still an active subtropical jet stream, which has created havoc for the tropics and will create havoc for forecasting in the winter. There's our QBO, westerly QBO. We're already seeing the negative features already showing up here, which is typical. This is a completely normal evolution of the QBO. Your changes go from the top of the atmosphere to the bottom of the atmosphere. So we're going to be in that positive state. Doesn't look all that strong though. So maybe that could be one of the contributing factors here that we're going to be studying. Meanwhile, our Siberian snow growth is just starting. Let the band begin. We're going to be watching this very carefully. If we are to believe model guidance over the next 10 to 15 days, we expect a lot of snow to build up here in Siberia. There's a lot of support from that from the GFS and the European guidance, both. You can even throw in the Canadian. So we'll see whether or not that verifies, but we are already running slightly above normal. I also keep an eye on the snow growth here in northern Canada because guess what? That's where most of our polar air masses come from. And the reason why I watch that is because the stronger the snow growth in northern Canada, the deeper and stronger the polar air masses are. So the question is, are we dealing with light syrup or are we dealing with real true maple syrup? You know? Are we dealing with an air mass that can easily get driven out? Or are we dealing with the polar air mass that when it comes in, it doesn't want to leave and creates a lot of problems like ice and whatnot? So those characteristics are very important to study to get a better handle on as we develop our forecast. Now, remember I was talking about, hey, look, the atmosphere isn't exactly behaving the way it should. This is a diagram of the EP flux. I talk about this a lot during the winter. It is the transport of heat in the atmosphere. And as you go up towards the North Pole, again, this is the equator, this is the North Pole, we have been averaging warm. Now, typically when we think of water vapor in the stratosphere, it has some interactions. One of those interactions is that it tends to screw around with ozone. Now, when we have low sun angle, or low sun activity, should I say, in the atmosphere, we tend to see our ozone begin to build up. So, is this creating an interaction with the ozone of breaking down or building up? Is this process leading to a warming overall of the entire stratospheric layer? These are questions I'm still struggling with because chemically speaking, HO2 interacting with O3 should lead to a breakdown, which should lead to cooling. Because much like with the active solar activity we have right now, right, it helps to break down the ozone in the ionosphere and stratosphere, which leads to cooling, which leads to contraction, which leads to above normal 500 millibar heights. On the other side, when we have no sunspots, you allowed for buildup of ozone, which would lead to warming in the stratosphere. And you get more interaction. So there's something going on here in the stratosphere that was not projected by A, your climate models, B, expectations with Tunga, and see what you would expect from solar activity. Because a model guidance would suggest, hey, throw the water vapor in there. We're going to cool the stratosphere, and cause a contraction of the stratosphere, expansion of the troposphere, and guess what? That interaction combined with CO2, and you're going to have massive cooling, and you're going to get very powerful 500 millibar heights and a lot of above normal temperatures. But somewhere in that process got short circuit because we shouldn't be seeing this. So a lot of interesting stuff. We have to see whether or not it continues to evolve as we move through the fall months. So I'm going to be keeping an eye on this quite a bit because it's kind of one of those wild cards that we're going to have to struggle with to figure out what to do with. So that is all of the data I wanted to share. So now it's time to answer all of your questions and see what you have here. Of course, as always, we start off with all the questions here in the premium chat. Then we visit YouTube and the other social media. By the way, on TikTok, I am approaching 1,000 followers. So if you are on TikTok, if you like using that, you don't have to, but if you do like to use it, give me a follow, get me to 1,000. I think that means I could go live on it. I'm not sure. I don't even know how long it's going to be available. Who the heck knows? But I always like to try things out because I like to reach new people, because you never know what you're going to find. So it's always fun. So let's see what we got here. Let's see. Hugo Jecker access to quote 80s music group Toto. I missed the rains in NYNJPA. Yeah, I understand that. When will we have a large synoptic rainstorm in our area? It feels like it hasn't rained in like forever, and when it does, it's always widely scattered. Honestly, I don't expect a huge transition until we get to October. Really, I don't. Because by October, we should have a stronger influence from La Nina, and you're going to have more thermodynamic interactions, i.e., stronger interactions between polar air masses and the tropical air masses and Pacific air masses, so i.e. bigger storms. So I don't think September you're going to see much of a change. Let's see here. Have noticed in the past couple of weeks the coronal holes are appearing again. Since areas with such holes, we're talking about the suns, are sunspot free, it's true. If that trend continues, as well as the sunspot numbers being more inconsistent, whether in retrospect this past summer will be seen as a solar max for this cycle. I think we are hitting the solar max. Okay, we got to about 210 sunspots in August. We're not seeing as many in September, but we'll be close. But typically when you see this dual max, because we had a burst in June, another strong one in July, and now August. In other solar maximums, that's usually how it went, and then we started to decline. We won't see the influence of a solar minimum influence that we're looking for a couple years. This is kind of a long game type scenario. When we're talking about solar impacts and sunspots and whatnot, I know a lot of people try to connect this to individual storms. That's a horrible way of going about this because the lag time between a sunspot's influence and the Earth's atmosphere is pretty long, longer than an extratropical low pressure system moving across, let's say, the mid-latitudes, okay? So it's not very good to set that up. But what you can do is look at the overall theme. And let's say you have months of low solar activity, that leads to a change in the structure of your atmospheric chemicals, right? So your components in the atmosphere, your ozone and whatnot, that gradually changes. This isn't like a on the dime type situation. It's a gradual change. So we're talking about years. This is a long game type scenario, right? Where right now we're dealing with the solar max. We're going to trend down towards the solar minimum. Probably see that influence by 2029, maybe 2030. But it's important to study it because now we're living in a world where now we can actually study this with raw data and we could test some of our theories. So this is why you follow it day by day, week by week, month and year by year. You get the idea. Also, west of Africa, there is a good high or low straddled in the equator. It would be high south of the equator, low north of the equator. That's typically what you see around this time of year. Nothing really all that impressive, though, in terms of development. This is at 250 millibars. Okay. Paul, I saw in the news that wildfires have been so extreme they're creating their own thunderstorms. Do fires have their own miniatures? How does this happen? Okay, so this is what happens. Thunderstorms develop because of rising warm air. Now, it gets pretty hot in a thunderstorm. So what you have is you have a lot of rising air. And everything that is associated with that rising air, you got a lot of dust particles, soot, right? So you have the basis for water molecules to settle on those little tiny components, right? It's called a nuclei, okay? So now as that's rising rapidly, it's also creating friction. So you got your smoke, you have your nuclei going up, you have water vapor in the atmosphere, they're all interacting, it creates a lot of friction, boom, lightning. That's generally what you have. You also see the same type of setup when you're dealing with volcanoes and any type of major fire event, because it's a combustion form. Thunderstorms are a form of combustion energy release. And so whether it's a fire or rapid transport of moisture up in the atmosphere, they're both forms of combustion release. Also at 70 millibars, there is still broad weak counterclockwise circulation around the pole, and 10 millibars is now developing with a feed from New England coast up to the pole. Yeah, again, we're probably about 2-3 weeks of really seeing a sustained polar vortex circulation. Let's see. Even the 18Z GFS isn't spinning up anything now. Yeah, I know there was a lot. Look, the European and the GFS a couple of days ago were spinning up some pretty impressive signals. And even on the YouTube videos, the one I did on Friday, I was like, I don't buy this. And it looks like I was right about that. So that looks good. Wonder if the water vapor that made it to the mesosphere is impacting solar radiation that makes it down to the stratosphere and is impacting how the radiation affects the water vapor in the stratosphere. That impact, if it would be any that would require mixing of levels. I haven't seen anything that would suggest it's gotten that far up. It's pretty much been capped in the stratosphere. I haven't gotten any data to say it's any higher than that. So I don't think that would be a factor. But I haven't found it. If you see data to suggest that, definitely let me know. Let's check out, see if there's anything going on. One question on YouTube that everyone always asks me: when will it snow? Well, let's use a little bit of climatology. I'm going to answer this question just because I always get this question. So what the hell? I'll put it this way. A white Christmas around here is about maybe 10% around the Poconos. So our snow season really, I know that everyone focuses on Christmas and, Frosty the Snowman and all that stuff in Hollywood. Well, except for White Christmas, because they actually recognize the fact that, hey, it's not snowing in New England, so what's going on, right? It was a whole movie based on that. You guys got to check that out. It's pretty climatologically accurate, too. It was pretty cool. I think it was during a La Nina year that they were doing the movie. But anyway, typically we don't really see snow rocking and rolling until we get past the holidays. You could get a minor snow event. That's certainly possible. But climatologically speaking, whether it's El Nino or La Nina, our main seasons is basically January 1st through February 15th. And then you can sometimes get your rogue storms the end of February and early March. That's, if you look at all of our climatological history, a lot of our winter storms have happened in this time period between when you're getting over your hangover from New Year's and when you're dreading having to figure out what to buy for Valentine's Day. That essentially is your time period for a lot of your winter storms for the northern mid-Atlantic. Then every so often we get a nice little gift in December, like we did back in 2010, or you get a nice little gift towards late February and March. And usually the March winter storms no one wants because you're ready for baseball and you're tired of this stuff and you just had 60 degrees the day before and now it's snowing and now you got a cold and it stinks and you want to wear shorts and it's horrible. So obviously, as one Simpsons character said, lousy Smarch weather. So yeah, but that's usually our time period. Anything on X or anywhere else?
That's another thing, but
I'm not surprised it's quiet tonight. We already had our landfall, and it's as quiet as it possibly can be with the high pressure system. So let's see if we have anything else here in the X channel. Let's see here. It already snowed in Siberian location. Oh, location. Okay. Yeah, absolutely. Siberian snowfall growth, though, is a funky little animal, okay? Because sometimes what you can have, okay, is that the snow advances too fast and it kind of short circuits everything. So it's much like ice skating. Meteorology is a lot like watching ice skating. You have two people come together. They're going to do this crazy jump and they have to hold each other up and all sort of stuff. If one guy's wrong, somebody's going to get their neck cut. So you don't want to have any mistakes. It's the same thing with meteorology. If you have snow growth that's too fast in Siberia, that could short circuit the whole process and throw everything off. So it's an interesting, funky little evolution. You throw in our influences with climate change, which, again, the world ain't burning up, but, I mean, the world's not going to burn up into a ball of fire. I can't believe some people are actually posting that crap. But it does influence. We are having influences. So, it makes the forecast more challenging, which I like, but at the same time, it can be a pain in the neck. Also, March snow tend to be wetter and heavier. Yes, that is true. That is very true. March snow, although some January storms, they had snowfall that's like cement. Either way, if you're not shoveling, I think this year I might do a live chat explaining how to shovel properly. I think that might be a cool thing. You know, maybe just do like a video, like, hey, this is how you properly shovel. You know, don't lift with your back, lift with your legs, stuff like that. All right. Well, it is 8:50. Well, almost 8:50. Update. It's the 8th inning, and the Braves are still losing. Again, the Nationals are playing spoilers, and I thank you very much. Thank you very much, Nationals, because that means the Mets will have sole possession of the wild card. They were 11 games under 500. That's amazing. But anyway, so I think we answered a lot of questions tonight. We went over a lot of stuff, and I think we're going to end it off here tonight where we're at. Again, for the Northern Mid-Atlantic, it's going to be pretty quiet all the way through Sunday. Have a threat for showers by the time we get to Tuesday and Wednesday. If you're on the coast, prepare for coastal flooding, developing Friday and continuing to be a growing threat as we move into next week. So be prepared now. Do what you got to do now to be prepared for that. So that way you're not caught off guard by the time it actually starts to form. In the meantime, as always, stay safe out there.